All right, sorry about that. Looks like we had a little catastrophic streaming failure last time, but where we basically left off was just showing that we can define our query here, and as the sheep, we can get the various information needed for the sheep, and we can execute the query that we care about. And again, if we don't care about some of these members, we don't have to query them, and if we care about other ones, we can query those. And so again, in GraphQL, we always get just the data that we want. It's very powerful. You don't have this overfetch issue and so on. So now let's make our sample data a little more complicated and make our resolvers a little bit more realistic. So first thing that we want to do is say one sheep obviously is not enough. Whoever heard of such a thing with only one sheep? So let's make a second sheep. And we can call this one test2. This is our cool second sheep. And we can give it some different parameters here just to mix it up. And so we can tell things are different. So now we have two sheep. It looks like we did not have accidentally deleted the parenthesis on our exit. So let's not do that. All right, looks good. Now if we go back to our app and see how it's going, we ask for the levels. Let's rerun this here. And we should get our new function loaded in there. Now when we get this, it'll give us both of our levels. So that's basically what the query function is doing. It's all pretty simple. But now we're going to make it slightly more complicated. So if we had a real database, like say we're using SQL, we can store an ID in a string, we can store a float and an int, but we can't store a rabbit hole or a single object. Those are going to be stored in a different table and then associated probably by some key lookup with the object they're associated with. It's a very common pattern in SQL or other databases. So when we do queries, we can actually utilize this. So in our query here, we may return, let's take out all the simple objects from this. So we're going to take out the exit and just have in our key things. The ID, name, description, width and height, and allowed time. And we'll do this to both of them. Okay, so now, if I go and run this, you'll see something pretty cool. Give you some insight into what GraphQL is doing. If I just say for each sheep, all I want here is the name, description, and the allowed time,
in a meeting?
It's no problem. Okay, so when we run that again, what we'll get is it will have no problem giving us this data. But now if I ask to give us the sheep, it just has null. So how can we do the sheep? Well, the way GraphQL will work is it will call this iteratively for every parameter. So let's take a look at a function that already does this over in our sample file. You'll see that for an object, any member has its own function associated with it. And let's copy one of these over so we can see the form. So if I have something like sheep, this is basically saying, hey, when you want to get this member of level, you're going to call this resolver. And the first argument to the resolver is this object itself. So it first will fetch the level object by calling this query function, and then it will call this sheep function and will pass in the level. And again, it's going to also have the data sources, but we're going to ignore that for now. And then what you have to do is just return just that one member. So for here, for example, this is where we would return just an array of sheep. So I could say and remember the format of the sheep. And let's just say we have 2 of these. So that could be our sheep, and then we can return that. So now we've written our first property level resolver. So let's restart our app here and take a look at what that does. Now, when I call the sheep, we get a weird error. Cannot return null for zloc. And again, that's because I once again put y when I should have had z. So that's always the issue with using 3D. You always forget which one is which. At least I do. Now you can see that it's going to return this data for us here. So that's basically how GraphQL works across the board. So what I can do now is I can define this for every one of these objects that had to be put here. So I could say, well, we need a, for all these missing objects here, I'm going to basically do the same thing. So for exit, again, I passed in the level. We'll ignore these parameters for right now. And then I'm going to do the same thing. And for each of these objects, I just construct whatever I want. The handy thing about using GraphQL for this is you can test your data pretty easily. And so I can have different test data here, I can have generators that generate mock data. You can get pretty fancy. So we have the exit, we need fences, we need electric fences. We need bushes, we need puddles, we need mud puddles, we need holes, we need dogs, and we need stars. And then we'll just start working our way on up the chain. So you just have to make sure that your resolver function name matches the name that you declared in your schema. Including being case sensitive and all that good stuff. And then if we want to be smart, we'll make the return object have the correct format. So for a fence object is a start and an ending point. You can see I almost did begin here with the Y and Z. Uh-oh. Be getting some network errors again. Hopefully we won't drop. We have to remember that on some of these, like fences, we actually have an array expected. Same with electric fences, it's an array. Bushes, it's an array. Puddles. Puddles are a different type of object. We still have xloc and zloc, an angle, but we also have width and height. But it is an array. Mud puddles are basically the same. Holes are a little bit different. So with holes, as you might remember, we have defined a hole as this object of rabbit hole that has an entry hole and an exit hole. So this is kind of fun because what we'll do is do this in two steps. First, we'll just make this thing return the rabbit hole. So we can say, for this hole, we're going to say there's an entry hole, and the entry hole is just going to have an xloc. Oh, look, we did this again. Look at that. And this really depends on how we end up writing this. We could have this be entry X and entry Y, exit X and exit Y, and make it one object. We could end up having a function that will return these things for the whole and so on. So we might tweak that later on to be exactly what we want. So for the dogs, we have the dog run, which again was the starting point and the speed. And finally, for stars, they're just simple objects. They don't even have an angle, but it is an array. So with that, we have all of our resolvers written for all the little subparts. And now we can start testing it. And again, this is like where you can start writing all your automated tests before you even have any information generated. So now I should be able to get things like the exit, I should be able to get any dogs, and again, because of its GraphQL, you just take the ones that you need and ignore the other ones. Then all those functions will start generating the results that I want. So now we basically have the skeleton of our resolvers all written. It's all working. We can do some more testing. We can add a lot of test cases here if we want. And next step is we have a choice. We can either already wire this into the app because it's actually working code here. That might be the next step. Or we could make this backed by an actual database. But I think what we'll do is next time we will connect this to our app so we can see how to actually call this from our application. So tune in next time and we will do that.